Good morning, Math 20s. This will be one of two videos from lesson 4 in Trig, and this lesson is in your workbook on page 167. Again, just like the first 3 lessons, this is an extremely content-heavy lesson. So a lot that you're going to be learning in this lesson that you really need to have a good grasp and understanding of in order to be successful in 30-1 trig. The nice thing though is once we finish lesson 4, we really have 2 lessons to go through after this, and both of those lessons are much quicker to get through, easier to get through, basically one concept that you need to know in the next 2 lessons. Okay, so this lesson we're going to start with, so what part 1 is going to be on is something called special triangles. And there's 3 different types of special triangles that you need to know like the back of your hand. So the first special triangle, it's called an isosceles triangle. And what an isosceles triangle is, it's a triangle that has 2 equal sides and 2 equal angles. So let's write that down. So 2 equal sides and 2 equal angles. So for example, an isosceles triangle, they'll always have a 90-degree angle. So these are going to be right angle triangles. So there's 3 special triangles, and all 3 of them are right angle triangles. The isosceles has 2 sides that are equal. And in an isosceles triangle, if 2 sides are equal, 2 angles are equal. So this angle is equal to this angle. Now, if you think about what you knew from Math 10, a triangle has 180 degrees, right? So this total triangle, these 3 angles add up to 180. So if I said, well, how many degrees would each of these angles be? You would say, okay, 180 degrees minus the 90 degree would give us 90 degrees. And then these two have to be equal, right? So what we would do is we would divide that 90 degrees by 2, and each of those angles would be 45 degrees. So again, an isosceles triangle has a 90-degree angle. This would be 45 degrees. This would be 45 degrees. This length and this length are the same, okay? Now, we need to know what this length, and the hypotenuse of this triangle is, and it's essentially going to be the radius. So I'll show you how we calculate this. If you had a square, what I'm going to do is I'm going to designate the square to have everything side length of 1, okay? And if I said, so this would be a square, so all the corners of a square are 90 degrees. So basically this would be 45 degrees and this would be 45 degrees. So you could cut a square into 2 isosceles triangles. If I said, well, what would the distance of this hypotenuse be? You would say, okay, well, that hypotenuse would be, let's calculate the distance. C squared equals A squared plus B squared. So C squared is equal to 1 squared plus 1 squared. C squared is equal to 2, and C would be equal to the square root of 2. So on my triangle, this is length 1, this is length 1, and this is the square root of 2. Remember that the hypotenuse has to be the longest side on our triangle. So if I go to my calculator and I type in what the square root of 2 is, the square root of 2 is 1.4, and that is going to be the longest side on this triangle. This is your first special triangle. So the first special triangle, it's the 45, 45, 90. Okay, so I'm going to write the first special triangle. It's 45, 45, 90. And you always have to memorize the sides of that triangle. So here I showed you how to calculate the side, but what you only have to remember for the 45, 45, 90 is just remember the numbers 1, 1, root 2. So if you could remember 1, 1, root 2, then those are your 3 sides of your triangle. And always remember that your hypotenuse is the longest side. So how does this work with trig? Well, all triangles with trig will fit on our Cartesian plane. So let's draw that 45-degree special triangle in quadrant 1 of our Cartesian plane. Let's label it, right? So put in your angles, 45. I'm not going to put in this angle. We know it's 45. Actually, I guess I will. 45, 45, and let's label everything. So 1, 1, root 2. What's going to happen is I'm going to say to you guys, I need you to tell me what the exact value of the sine of 45 is. So if you go back up to this lesson, the title is Special Triangles and Exact Values, okay? So up to this point, if I would have given you this in grade 10, the sine of 45 degrees, here's what you would have done. You would have gone to your calculator, made sure that you were in degree mode, and you would have typed in the sine of 45 degrees. You would have gotten this decimal here. This decimal is not an exact value. I need to know what is this number as a fraction. That would be an exact value. So in order to tell me what the sine of 45 is as an exact value, you need your special triangle. So we know that sine is 7 yellow rabbits, right? Sine is y over r. So if I go to my triangle, what is y and what is r? So this is my y, this is my x value, and this is my radius. So y over r would be 1 over root 2. This 1 over root 2, you guys, is an exact value, right? Watch what happens when I type in 1 divided by root 2 on my calculator. So 1 divided by square root of 2 gives me 0.707. On a test in 20-1 and 30-1, if you see the word exact value, that is your clue that you need special triangles, and you cannot give me your answer as a decimal. You have to draw out your special triangle and figure out what the exact value is. Okay, here's the thing though. From rationals, do we leave an answer with a radical in the bottom? And you should be saying no. So the sine of 45 degrees, we got that the exact value of that is 1 over root 2. So let's just rationalize that. So times root 2 times root 2, and the sine of 45 degrees is actually rationalized, would be root 2 over 2. And that would be my answer. And if I go to here, let's just check that answer. Square root of 2 divided by 2. There we go. Okay, so yes, 1 over root 2 is correct, but remember, we always rationalize in math. Okay, let's do the cos of 45 degrees. So the cos of 45 degrees, we know that cos, if sine is 7 yellow rabbits, cos is x over r. So I'm going to go to my triangle, my special triangle, and that would be 1 over root 2. And again, I'm going to rationalize 1 over root 2. So 1 over root 2, multiply top and bottom by root 2. And the cos of 45 degrees is equal to root 2 over 2. Again, let's check that on our calculator that we're correct. So in 10C, it was good enough just to type in the cos of 45 degrees. But now I need to know what that exact value is. And that's root 2 divided by 2. Okay, let's do the last one, tan of 45 degrees. So tan you just have to memorize. Tan is y over x. Going to my special triangle, here's y and here's x, 1 over 1. So the tan of 45 degrees, the exact value is 1. And I could check that on my calculator, see if I'm right. 1. Okay, so those three are your exact values for the sine of 45, cos of 45, and tan of 45. Your book wants you to just memorize these numbers. I recommend not memorizing them. You'll see from this lesson there's far too many numbers to memorize. What I tell my students, I want you to memorize this 45, 45, 90, which is 1, 1, root 2. I always get my students, every single time they do questions in trig now, if they're asking about a 45-degree angle, they're drawing this triangle here. And if you can just memorize 1, 1, root 2, you'll be able to get all three of these. Okay, let's do, so I've changed the questions in your book. So I just want you to draw somewhere on in your workbook 2 Cartesian planes. And we're going to now do the other 2 special triangles. And the other 2 special triangles, they are the 30, 60, 90-degree special triangle. Okay? And your book starts with the 60-degree. So what you have to memorize for 30, 60, 90, I always say to my students, I want you to memorize the numbers 1, 2, root 3. So if you can memorize 1, 2, root 3, you will be able to do this 30, 60, 90-degree triangle. Okay? So let's set this triangle up. So they want my angle to be 60 degrees. So draw yourself a Cartesian plane. Remember that I said all three of these are right angle triangles. And if they want the angle to be 60 degrees, that would be this angle here. Now, if this is 60 and this is 90, what would this be to give you 180? So think about that. If this is, what's 180 minus 90 minus 60? That angle up there would be 30, right? So that's why this is called a 30, 60, 90-degree triangle. Okay, so now we have to label, how do we figure out which side gets 1, which side gets 2, which side gets root 3? So between the numbers 1, 2, and 3, ask yourself, what's the smallest number, right? Between the 1, 2, and the root 3. And actually, let's type in what root 3 is. So let's figure out what root 3 is. Root 3 is approximately 1.7. Okay, so 30, 60, 90, 1, 2, root 3. That's all you have to memorize. In order to put your numbers down, 1, a 2, and a root 3, say to yourself, what's the smallest number between a 1, a 2, and a 1.7? And that answer is 1. The smallest number goes across from the smallest angle. So between 30, 60, and 90, the smallest angle is 30. So directly across from your smallest angle is your smallest number. Now we just have to figure out where the 2 and the root 3 goes. Well, think about it. Your hypotenuse, or your radius, is the longest side. So what do you think the radius gets? What does my hypotenuse gets? Do you think I'm going to put a 2 there or a root 3? 2 is bigger than 1.7. So 2 would go here, and root 3 would go there. So again, memorize 1, 2, root 3. The 1 is the smallest number, and it goes across from your smallest angle, which is 30 degrees. Your hypotenuse is always your longest side, and between a 2 and a root 3, 2 is bigger, so by default, root 3 goes there. Now that we have this, we could do our exact angles. So label your x and y. That's your x value. This is your y value. That's your radius. Sine of 60 degrees, sine of 7 yellow rabbits. Sine of 60 degrees would be y, I'm just going to make this a bit cleaner, y over r would be root 3 over 2. My denominator's rationalized, there's no radical down there. So I'm going to argue that the sine of 60 degrees, the exact value, so let's write that, exact value is root 3 over 2. Let's check on our calculator. So type in sine of 60, and that is an exact value is root 3 divided by 2. There you go. So this is not an exact value. This is an exact value. Okay, let's do the cos of 60 and tan of 60. If sine is y over r, cos is x over r, so cos would be 1 over 2. And that's the exact value of the cos of 60 degrees. The tan of 60 degrees is y over x. So going back to my special triangle, there's y and there's x. So that would be root 3 over 1 which is just equal to root 3. And again, let's confirm. Let's type in the tan of 60 degrees. Is that's what you would have given in 10C as an answer. I will not accept that answer in 20-1 or 30-1. So the exact value of the tan of 60 is root 3. Okay, 30 degrees, it works so there's really only actually two triangles that you're memorizing. You're memorizing this 45, 45, 90, and the 30, 60, 90. So 60, 30 degrees, it's the same triangle as what we just did. 30, 60, 90. The only thing about this is the angle here at the origin now has to be, in this example, it was 60. Now the angle at the origin, they want to be 30. So I say, okay, I'm now going to draw a 30-degree angle. Here's my 90 degree, and this guy would have to be 60. So I'm going to do my same counting, 1, 2, root 3. You guys will just eventually memorize that root 3 is 1.7. Then we're going to do the exact same rule. So you're going to say between the number was 1, 2, and a 1.7, what is the smallest number? The smallest number is 1. That always goes across from the smallest angle. So between these three angles here, the smallest angle is 30 degrees. So across from the 30 degrees, the number 1 goes. So that's where the number 1 goes, right? Because across from my 30 degrees would be that side there. Then you just have to put in your 2 and your 1.7. So ask yourself, well, what would be the hypotenuse? What's bigger between a 2 and a 1.7? So 2. And by default, the root 3 would go there. Now we could do our sine of 30, our cos of 30, and our tan of 30. So sine of 30 degrees, sine is 7 yellow rabbits. Sine of 30 degrees is y. So y over r, which would be 1 over 2. That's the sine of 30 degrees. Cos of 30 degrees is x over r, which would be root 3 over 2. And the tan of 30 degrees is y over x, which would be 1 over root 3. Let's rationalize this. And if we rationalize it, the tan of 30 degrees is root 3 over 3. Okay? And this is going to come into play in 30-1 in a major way with something that's called the unit circle. Just to let you know, you guys, when you get to 30-1 and I ask you the sine of 30 degrees, the cos of 30, and the tan of 30, you'll no longer be using calculators when you get to trig in 30-1. Because if you think about this, I don't need a calculator to do this. If I've memorized this 30, 60, 90 degree triangle, I don't need a calculator to give me these exact values. Okay, this page here, it's going to be very similar to identical to what we just did. So it's basically redoing what we just did, reinforcing everything. So I want you to scroll down to this chart here. And again, it's wanting us to fill in like the sine of 30 degrees, cos of 45, or sorry, sine of 30, sine of 45, sine of 60. And your book tells you to memorize this whole table. I say to my kids, please don't memorize this table. Let's do our 45-degree triangle. So what I want you to do, draw yourself a Cartesian plane, right? So let's see how you guys understood that the first part of this video. So let's draw our 45-degree triangle. So remember 45, it's 45, 45, 90, right? That was our isosceles. And what I told you, the only thing you have to memorize for this is 1, 1, root 2. That's it. So draw yourself a 45-degree isosceles triangle. and label it. If it's isosceles, you get a 1, this side gets a 1, and my longest side is root 2. Now, let's label our y, x, and our r. So that's x, that is y, and this is r. Now see if you could do fill in this. Without looking at your last page, see if you could do this. So what would the sine of 45 be, the cos of 45, and the tan of 45? Remember that sine is 7 yellow rabbits. So the sine of 45 degrees would be 1 over root 2. And this we have to rationalize, which would be, if you rationalize 1 over root 2, you get root 2 over 2. That's the cos, or sorry, that's the sine of 45 degrees. Cos of 45 degrees, what would that be? So cos is x over r. X is 1 over root 2. And if you rationalize it, you get the same thing as sine of 45, so root 2 over 2. Tan of 45, tan is y over x. Go to my special triangle, and y is 1, x is 1, and the tan of 45 degrees is equal to 1. Okay, now what I want you to do, you'll probably need to get a scrap piece of paper for this because you don't have much room. To see if you're understanding this, see if you could draw, let's do 30 degrees. So draw yourself a Cartesian plane. 30 degrees, that's your 30, 60, 90 degree special triangle. What do you have to memorize? 1, 2, root 3. Root 3 was approximately 1.7. So on a scrap sheet of paper, draw yourself a 30 degree, 30, 60, 90 degree triangle. If they want 30 degrees, that's the angle here. This would be 60. Okay, I need to figure out where the 1, 2, the root 3 goes. So the smallest number is 1, and that goes across from my smallest angle, which would be there. My biggest number is 2, which would be my hypotenuse. By default, that's where my root 3 would go. Now we're figuring out 30 degrees. So what's the sine of 30, the cos sine of 30, the cosine of 30, the tan of 30. Sine is 7 yellow rabbits, so 1 over 2. The cos of 30 is x over r. X is root 3 over 2. And the tan of 30 is y over x, and y is 1 over 2. Sorry, that's incorrect. Tan of 30 is y over x, y is 1, and x is root 3. Okay, I would need to rationalize that though. So 1 over root 3 times root 3 and times root 3. The tan of 30 degrees is really root 3 over 3. On your scrap sheet of paper, let's draw one more triangle, but 60 degrees this time. So this angle we got to change to 60. So let's erase this. Let's draw our 30, 60, 90 degree triangle one last time. So it's basically 3 triangles you're memorizing. This would be 60 degrees. This would be 30. Here's 90. Across from my 30 is my smallest number, which is 1. My 2 is my hypotenuse, and my root 3 is always across from my 60. Sine of, we're going to change this now to 60 degrees. So now they want 60. Sine of 60 is 7 yellow rabbits, which would be root 3 over 2. Cos of 60 is x over r. X is 1, and my radius is 2. And tan of 60 degrees is y over x. Y is right here, root 3 over 1, which is just equal to root 3. So once again, your book says memorize this whole table. I don't memorize anything, right? There, I don't memorize any of these 9 numbers in my table because you're actually going to have much more than 9 numbers to do. So I'm like, okay, we don't have time for that. If you can memorize those 3 triangles, 30, 60, 90, 60, 30, 90, and 45, 45, 90, you can get any of these 9 numbers. The last thing that we have to do for these special triangles are the numbers 0 and the numbers 90. Okay, so again, this is going to be really big in 30-1. So remember that I said everything kind of goes along this circle, right? So we start at 0 degrees and we get to 90, here we're at 180, here we're at 270, and back to 360. So this is going to be something called the unit circle, which we'll introduce in Math 30. And what you need to know for 20-1 is you need to know the coordinates at 0 and at 90, the ordered pairs. So if I said, okay, well, what is the ordered pair at 0 degrees? So what would that ordered pair be? And remember ordered pair, you guys. Ordered pairs are always x comma y. So what we would do is we would say, okay, that ordered pair, the x value here, we're going to say it's always going to be like this distance will be 1. Like that's our radius. And on the unit circle, our radius is always 1. So if I said, well, what would that x value be? The x value would be 1. And the y value here, y is at 0. If you take this radius of distance 1, so unit circle, the radius is always 1. And I move that radius up to here. Okay, and that radius is 1. It's a distance of 1. So now this radius is 1. And I said, well, okay, what would this coordinate be? You would say, okay, well, that x value, x is now at 0, and y is at 1. And then these are the only 2 coordinates you need to know for 20-1. In 30-1, I'm going to say, okay, well, what would the ordered pair be over here? And you would say, okay, well, this radius, right, I'm going to spin it down here. So there's my radius now. If the radius is always 1, and I said, well, what's this ordered pair? You would say, okay, that x value is at -1, and the y value's at 0. Down here, that ordered pair, the x value would be at 0, and the y value would now be at -1. So we really only need to know these 2 points for 20-1. So if I said, what's the sine at 0 degrees? So here's 0 degrees. Sine at 0 degrees. You know that sine is 7 yellow rabbits. Y is 0 over r. The radius is always 1 on the unit circle. So 0 divided by 1 is 0. The sine of 0 degrees is 0. So sine of 0 degrees is 0. What's the cos of 0 degrees? So the cos of 0 degrees is x over r. Now I got to find my x coordinate. There's my x coordinate, 1. My radius is always 1. 1 over 1 is 1. Tan of 0 degrees, tan is y over x. And y is, here's y, 0 over x, which is 1. 0 divided by 1 is 0. So if you type in the tan of 0, 0 will pop out. These are your three exact values at the sine of 0, the cos of 0, and the tan of 0. Now we're going to do the same thing for 90 degrees. So 90 degrees is right here. And if I said, well, what is that ordered pair at 90 degrees? Your x value is at 0. And my radius, or the height of this, the radius is always 1 on our unit circle. So the sine of 90 degrees, 7 yellow rabbits. So 1 divided by my radius, and would be 1. 1 over 1 is 1. Cos of 90 degrees, cos is x over r. X is 0. My radius is going to be 1. Cos of 90 degrees is 0. Tan of 90 degrees is y over x. Y is 1. X is 0. 1 divided by 0 is undefined. You could never divide a number by 0, and you learn that in rationals. So the tan of 90 degrees is actually undefined. And if I show you that on your calculator, and you type in the tan of 90 degrees, you will get an error. So it's undefined. And then in 30-1, we'll look at the graphs for sine, cosine, and tangent, and you will be able to see in 30-1 exactly why that's undefined. So again, explain why tan of 90 is undefined. Here's how you would explain it. The tan of 90 degrees is equal to, we know that tan is equal to y over x. So tan of 90 degrees is equal to y over x. At 90 degrees on our circle, 90 degrees would be right up here. 90 degrees, that ordered pair, the x value is at 0, and the y value, the radius, is 1. So that would be at 1. And tan is y over x, which is 1 over 0. And then you would say you cannot divide by 0. And you'll get a number that is undefined if you do divide by 0. Okay, that's going to be the end of the first part. So really, you need to just understand, you'll see with this part 2, all of your questions are going to involve those 3 special triangles, so the 30, 60, 90, and the 45, 45, 90. You need to understand that. So make sure you could draw those triangles. And the only thing that I want you to do right now to practice is question 1 in the homework. And if we quickly look at question 1, so let me go to the homework. Oh, for whatever reason, mine has all the solutions. That's fine. So question 1, again, is you're just completing this chart. So when you complete this chart, what I want you to do is I want you to draw off to the side your 45, 45, 90, and see if you could label 1, 1, root 2. So you have to memorize that. And then draw off to the side in your homework a 30-degree triangle. So 30, 60, 90. And you have to memorize 1, 2, root 3. And you have to know where do you place those. And then the third triangle that I need you to draw to show that you understand this, 30, 60, 90 could be written with the 60 degrees here, the 30 degrees here, and the 90 here. And again, how would you label that 1, 2, root 3? Okay, so just do question 1. When you think you have your special triangles down pat, you understand that, then you can watch part 2, and we will finish off this lesson.